A warm welcome to Valio's webinar for B2B professionals on what's new in milk fat and infant nutrition. If you have any questions regarding the webinar, please send them through the chat link. First of all, we should always keep in mind that breast milk is the best choice and is unparalleled in providing the ideal food for infants. However, if babies are not best breastfed for whatever reason, they should be fed safely on the best available nutritional alternative. Today, we will talk about milk fat as the source of fat for infants. My name is Anu Turpeinen, and I work as Nutrition Research Manager at Valio R&D in Helsinki, Finland. Health effects of different dietary fats have been my main research interest from the very beginning of my academic career. I worked as a researcher at the University of Helsinki for over 10 years, and after defending my PhD, I spent 2 years in the US studying the metabolism of long-chain PUFA in infants. I joined Valio in 2008, and since then, milk fat and also other bioactive components of milk have been in my research focus. If you wish to get in touch to talk more about milk or milk fat, please contact me through LinkedIn. Valio was established more than a century ago by Finnish dairy farmers with the purpose of exporting good quality butter overseas, where there was high demand. So dairy fat has been in the core of our business from the very beginning. Today, we offer pure, natural dairy ingredients for the food and nutrition industry. We serve customers globally with innovative solutions to all age groups. We have a long history in baby food business, consumer products, and most recently, we have ventured into nutritional solutions for the elderly. Our expertise and ingredients can be used in various applications. And we still export butter, among other ingredients and consumer products. In our R&D, we have a long history of research and innovation. Valio R&D was headed by Professor Virtanen, in the picture, for 50 years. And during that time, he received a Nobel Prize in chemistry for his discovery on how to preserve the nutrient value of grass fed to cows during the long Nordic winter. Due to improved nutrition, the cows were able to produce high-quality milk also in the winter, when grass did not grow. Professor Virtanen believed that well-being is the key to everything. His legacy still lives on. We put a lot of effort in R&D and use science to make food that improves everyday lives. We have over 300 patents and a history of successful science-driven innovations, such as lactose-free products and products with probiotics. In all our products, we use fresh Finnish milk, which has been shown to be among the cleanest in the EU. We have healthy cows fed with GMO-free feed and pure milk with 0 traces of antibiotics. The quality of the production chain is closely monitored and regulated, so you can be sure to get high-quality dairy ingredients that are safe for even the most vulnerable group of consumers, such as infants. Let's then go to our topic, which is milk fat, one of the most complex natural lipid mixtures with a unique fatty acid composition, distribution, and numerous complex lipids. It's no wonder that milk fat has also been in the headlines related to infant nutrition, as scientific research and clinical studies have increased our knowledge about specific fat compounds. And as we know that the foundations for optimal health are laid during the first 1,000 days of life, and the best window of opportunity to secure good health also later in life is in the very beginning. So, breast milk fat composition is the golden standard. But if we look at the alternatives, different fats used in infant formulas, they differ in many aspects. First of all, in the fat globule size, in the positioning of fatty acids in triglycerides, and in the composition of the membrane covering the fat globules. In my presentation, I will talk about these differences in more detail and go through research findings, how these fat components affect the development and well-being of the infant. Natural fats contain fat globules of different sizes. In human milk, fat globules have a wide size distribution, ranging from below 1 to up to 15 micrometers, with an average size of 3 to 4 micrometers in mature human milk. As can be seen in the pictures, a similar size distribution is found in raw cow's milk, but in plant oils, oil bodies are significantly smaller, from 0.5 to 2 micrometers. Although raw cow's milk resembles human milk, during manufacturing, infant formulas are homogenized, and the size of the fat globules is decreased to about 1/10 of the original size. And the average droplet size also in dairy fat-based formulas is only about 0.4 micrometers. We are currently studying how we could, with less processing, maintain the size distribution of raw cow's milk fat in formulas without compromising product quality and sensory characteristics. We see this as another step closer to human milk that we should take, as there is evidence that the fat globule size affects fat digestion and absorption in infants, and human milk fat is digested and absorbed more efficiently than fat in infant formulas. And the size of the lipid droplets is one explanation that has been proposed. Another is the surface coating of the fat globules, which I will discuss next. The milk fat globule membrane, or MFGM, is the membrane surrounding fat droplets in human milk and also in cow's milk. It's a unique feature of milk of all mammals. A similar structure is not found in plants. The membrane consists of a trilayer of complex lipids, such as phospholipids, gangliosides, glycolipids, sphingomyelin and other sphingolipids, and also cholesterol. These lipids are known to have a wide range of functions, for example in brain development and functioning, intestinal maturation, and immune defense. In addition to lipids, at least 200 different proteins have been identified, which are involved in many cellular reactions. They have been shown to have antimicrobial properties. They act as growth factors, and they may be involved in cell signaling, defense mechanisms, and lipid metabolism. But there is still a lot to be studied about the different proteins. So all in all, MFGM contains a multitude of bioactive components. Dairy fat in general contains MFGM, and we can also separate fractions such as buttermilk, which is enriched in MFGM and can be used to increase the level of complex lipids in infant formulas. There is a growing number of clinical studies which have reported benefits of MFGM in infants. Enhanced cognitive development was first reported in a Swedish study in which infants who were fed MFGM-enriched formula until 6 months of age had significantly higher cognitive scores at 1 year's age compared to infants who were fed a standard formula. Also, the cognitive score was not different from results for breastfed infants. In another study, infants fed MFGM and lactoferrin supplemented formula scored higher in cognitive, language and motor development tests than infants given standard formula, also at 1 year's age. One study investigated the effects of a specific group of lipids found in MFGM, the gangliosides, which were supplemented until 6 months age, and increased scores for hand and eye coordination and general IQ were reported. In somewhat older children, preschool-aged, parents reported better behavioral and emotional regulation after the children consumed chocolate milk enriched with MFGM compared to children receiving the same milk without MFGM. MFGM seems to be likewise beneficial in strengthening children's immune system, with several studies reporting benefits. It was found that milk formula with added MFGM reduced incidence of acute otitis media and episodes of diarrhea, as well as use of antipyretics. From preclinical studies, there is increasing evidence that MFGM enhances gut maturation, promotes a similar gut microbiota as in breastfed infants, and may prevent intestinal inflammation. Generally, these effects reported for MFGM have not been attributed to any single group of lipids or proteins. Rather, it seems probable that effects of both lipids and proteins are involved. Cholesterol, also a component of MFGM, often has a negative image as a risk factor for heart disease. But in fact, it's essential for normal growth and development. Cholesterol is an integral part of all cell membranes. It's a precursor for steroid hormones and bile acid synthesis, as well as essential for the functioning of neurons. Actually, the organ with the highest cholesterol content in the body is the brain, with about 25% of the whole body cholesterol. The significance of cholesterol for the brain is illustrated quite well by the fact that brain cholesterol metabolism is separated from the rest of the body, so that brain cholesterol level can be accurately regulated to keep the brain functioning properly. Studies show that breastfed infants have higher serum cholesterol concentrations than formula-fed infants. This is no wonder, considering how high breast milk is in cholesterol. Cow's milk also contains cholesterol, and so do milk fat-based formulas, although less than in breast milk, whereas vegetable oil-based formulas contain no cholesterol. In a clinical study, adding MFGM to a standard formula resulted in a blood lipid profile closer to that of breastfed infants. What is interesting is that although breastfed infants have higher cholesterol levels, a few studies have reported lower serum cholesterol levels for adolescents and adults who were predominantly breastfed during infancy, compared to those who received infant formula. The hypothesis behind this is that in breastfed infants who obtain cholesterol from the milk, endogenous cholesterol synthesis is downregulated, whereas in infants receiving formula with no cholesterol, endogenous synthesis is programmed to be upregulated to secure cholesterol needs of the body, and it remains upregulated up to adulthood. So the first year of life is really significant regarding body cholesterol metabolism, with early nutrition playing a critical role. Another component of MFGM are phospholipids. And with phospholipids, it's not only the quantity, the more the better, but also the composition that is of significance. Phospholipids make up as much as about 30% of the total lipid weight of MFGM. They have a diverse range of functions. They are involved in cell signaling, production of neurotransmitters, in gut maturation, immune reactions, and cognitive functions. And each individual phospholipid group has specific functions. In the figure, 4 major classes of phospholipids, and sphingomyelin are presented. As is visible, the phospholipid composition in cow's milk MFGM is quite similar to the composition in breast milk. For example, sphingomyelin is one of the major phospholipids in human milk and also in dairy fat, but is not found in plant phospholipids. Sphingomyelin is involved in the development of the nervous system, and levels have been positively correlated with cognitive performance during the first 2 years of life. So dairy fat-based formulas contain milk phospholipids, and the levels can be even further increased by using, for example, buttermilk, up to levels found in breast milk. Let's then talk a little about the structure of triglycerides. Triglycerides consist of 3 fatty acids attached to a glycerol backbone. And it's not insignificant in which of the 3 positions a fatty acid is located. Regarding infant nutrition, especially the location of palmitic acid, C16-0, has been shown to be of importance. Palmitic acid is the major saturated fatty acid in human milk and usually represents about 20 to 25% of human milk fatty acids. In human milk, the majority of palmitic acid, about 70%, is located in the middle or the SN2 position, with typically oleic acid on both sides. This palmitic oleic structure is OPO, which I'm sure many of you are familiar with. In bovine milk, about 35 to 40% of palmitic acid is in the middle position, whereas in most vegetable oils, the figure is below 10%. So there are really big differences between fats in the proportions of natural OPO. So why does this matter? Well, the positioning of fatty acids makes a difference already during the digestion of fat in the small intestine. If palmitic acid is in the outer, the SN1 or SN3 positions of triglycerides, when these fatty acids are cleaved from the glycerol backbone, palmitic acid forms insoluble soaps with minerals such as calcium, and both fat and minerals are not absorbed, but instead they're lost. However, when palmitic acid is in the middle position and oleic acid is on the sides, the OPO structure, as is predominantly in breast milk, both fat and calcium are efficiently absorbed. For infants fed only on milk, this may have significant effects on nutrient intake. The enhanced calcium absorption has been associated with increased bone density, and clinical studies have also reported many other effects for OPO on infant well-being. Supplementing infant formulas with OPO has improved gut comfort by affecting stool composition, preventing constipation, and increasing beneficial lactic acid bacteria and bifidobacteria in the gut. Probably related to the enhanced gut comfort, reduced crying and improved sleep have also been reported. So OPO has broad effects on growth, gut well-being, and immune function. But we should keep in mind that these are results from clinical studies. So far, there are unfortunately no accepted health claims for OPO. We recently conducted a study in collaboration with the University of Turku in Finland and analyzed commercial infant formulas for the positional isomers of selected triglycerides. We had both milk fat-based baby formulas and formulas that contained only vegetable oils. They were analyzed with mass spectrometry using a sensitive MSMS. I have here results for natural OPO, shown as the percentage of palmitic acid in the SN2 position of total palmitic acid. The blue bars in the figure are milk fat-based formulas, and the greenish bars are vegetable oil-based formulas. And none of these formulas contained added OPO. The difference between milk fat-based and vegetable oil-based formulas is quite visible, with a several-fold greater proportion of natural OPO in the milk fat-based formulas. Although altogether 21 triglyceride structures were analyzed, and results are presented in a paper which has just been published in Food Chemistry. The reference can be seen below the figure. So if you're interested in the rest of the results, please have a look at the paper. Or you can contact me and I can send you the PDF. So, to summarize, fat matters for infants. Optimal fat globule size ensures efficient absorption of fat. The lipids and proteins in MFGM enhance cognitive functions, improve immune function and resistance to infections, and have beneficial effects on gut health. The positioning of fatty acids in triglycerides affects absorption of nutrients, gut well-being, and infant growth and development. So milk fat has natural similarities with breast milk fat, which can provide benefits when creating nutritional alternatives if breast milk is not available. A few words about the solutions we offer for the baby food industry. Valio has a long history in baby foods, several decades of experience in studying the nutritional needs of infants and creating solutions for infant formula manufacturers. In 1955, we launched the first infant formula powders and were the first in the world to launch ready-to-feed UHT infant formulas in 1973. We can offer solutions and expertise for different applications and needs, from ingredients to final consumer products. Our experts can also help you with recipe design and calculation to ensure optimal composition and nutritional content for your baby food products. Briefly about our ingredients and solutions. In infant-grade ingredients, we have demineralized whey powders, also partially hydrolyzed, a variety of milk powders with different fat, protein, and carbohydrate contents, buttermilk, organic and lactose-free powders. We can provide base powders from basic blends to complete formulas, standard codex and EU recipes, or fully customized solutions. We can make complete powders in bag-in-box or tin and ready-to-feed formulas in Tetra. If you would like to know more, please contact my colleague, Sales Manager Sari Vahla. She is happy to tell you more about our solutions. And if you have questions regarding this webinar, please send them through the chat link. Or you can contact me or Sari on LinkedIn anytime. Thank you for attending our webinar.